In this lesson, we're going to take those methods of factoring and solve quadratics. There are many methods of solving. In this lesson, we're going to take a look at solving by factoring and using the square root method. Before we get to solving quadratics, let's go over a few things. The degree of a polynomial indicates the possible number of solutions. And we are going to focus on quadratics. Therefore, the most possible solutions are going to be 2. So graphically, the solutions for solving quadratics is where the graph crosses the x-axis. Algebraically, the solutions are the values of x that make the equation true when y is 0. So we're looking at the x-intercepts. The graph can cross the axis at 2 points in our first example. This quadratic has 2 solutions, 4 and 8, the x-intercepts. Or a graph, a parabola, can have 1 solution and touch the x-axis with its vertex. In this example, the solution to this quadratic is 2. The third possibility for a solution of a quadratic is where it crosses no points on the x-axis. So in this quadratic graph, this parabola has 0 solutions. Our graph does not cross the x-axis anywhere. So we can have 2 solutions, 1 solution, or 0 solutions. When we have 2 real solutions, the graph crosses 2 points. When we have 1 real solution, the graph touches the x-axis at that 1 point, and it is also the vertex. And again, we can have no real solutions where the graph does not touch or cross the x-axis at all. So we can have 2 real solutions, 1 real solution, or no real solutions. The goal of solving quadratic equations is to determine where the graph crosses the x-axis. And graphically, it's easy to identify. But we're going to learn how to identify it algebraically as well. So there are many terms used for the x-intercepts. Sometimes it's called the zeros, the roots, the solutions, or the x-intercepts. So all of these words are interchangeable. They all mean where the parabola crosses the x-axis. So let's talk about the x-intercept algebraically. We have a linear function, an exponential function, and a quadratic function. Let's take a look at where each of these crosses the x-axis. And let's identify those ordered pairs and see what they have in common. In our linear function, the x-intercept is 4, 0. In our exponential function, the graph crosses at 2, 0. And our quadratic crosses at 2 points, -1, 0, as well as 3, 0. What do you notice about all of these ordered pairs? Exactly. So our x-intercept, as we have learned in the past, is when the y value is 0, or sometimes we just use f of x. So the x-intercept or intercepts is when your output is 0, when y or f of x is 0. So let's take a look at this linear function. And we don't have a graph to identify the x-intercept, so let's do it algebraically. Remember, the x-intercept is when y is 0. So we're simply going to plug in 0 for y and solve for x, and that will be the x-intercept, no matter what function you're looking at. So we're going to isolate x. Now we're going to multiply by the reciprocal, and x is going to equal 4. This means that this linear function crosses the x-axis at 4. So now we're going to get into 2 of the 4 methods that we will learn in how to find the x-intercepts, the solutions, the roots, algebraically. We're going to take a look at factoring, which we have learned how to do, many methods, and we're also going to look at the square root method. Remember, we're going to set each function equal to 0. We're going to substitute y or f of x for 0, and we're going to solve for x.